Hello. Thank you to the organizers of the workshop very kindly. My name is Paola Di Maio. I'm a researcher and I will be speaking today about some findings, give an overview of the space that I'm working in and some findings which I think contribute to forming a direction for possible future standard work that KW can do. So my perspective is I'm coming from knowledge orientation, AI, KRC. I chair WPC AI, KRC, community with knowledge representation. And knowledge representation has been, which I'm going to spare you what it is, because it's a very long story, but you can look it up, is very useful. It has been very useful to help me understand the complexity, grasp, represent, or capture the complexity of contemporary AI landscape, and especially knowledge presentation facilitates and supports interoperability. So my personal motivation is that I need, like many other people, to reduce screen time. So we have to reduce or remove the dependency on the visual interfaces and the screen. Also, we need to we would like to leverage, we can leverage more the power of voice interaction, because voice is very powerful and the technology is there. However, for some reason until now it wasn't really that used because of the proliferation of new AI apps. AI voice is being integrated, can be, is going to help us a lot to facilitate adoption and improve the quality of the interaction. So we are also looking at using voice to develop the capabilities and the of AI in terms of interactivity and autonomy. So the talk very briefly is going to look at these new technologies and identify some gaps in the usability. Okay. So this are figures or indicators of the technical breakthrough. The technical capabilities are very advanced, almost real-time speech, with a number of products, models, technologies supplying completely up to the no more technical challenge. And amongst these, OpenAI, Helium, Cartesia, Moshi, and others, with a bunch of figures which I will let you read. Market figures, 2.4 billion projected to become 47 billion in the next 10 years. Very large segment of the AI app market looking at voice, building voice apps. Every single AI agent is now integrating with voice, digital assistants. These are estimates, but can give an idea of becoming 12 billion, 26, and large segments of the market using voice assistants one way or another. The majority using the voice assistant daily. So adoption is moving towards increasingly complex tasks and workflows. with outcome-based pricing rather than time-based, and the number of new players coming onto the market. I don't have figures to show how long these companies actually stay. There is the ecosystem is very dynamic, and a lot of companies are coming into the market and then being acquired very quickly. So this is dynamic, but a lot of these are probably familiar to those who into the space. So we have speech to text. This is the stack, the traditional stack, speech to text, going into language models and being translated back to speech with platforms facilitating orchestration. Best in class latency, last time we looked was 510 milliseconds. Natural language processing capabilities and voice synthesis with a realistic performance, so human-like voices, and with companies, non-companies. Plus, the multilingual, so these features are available in multiple languages. So, emerging capabilities include emotion and prosody preservation in the speech-to-speech models. Speech-to-speech models are there in principle, although they're not fully rolled out. They're kind of being progressed. Voice biometrics for security, real-time meeting transcription. I have used Otter, no, it's very good. This works very well. You have natural conversation, and at the end of the meeting, you get transcript, minus the swear words. So the utterances and things that shouldn't be there. So really good job. And conversational therapy box. This is very interesting space. Application domain. I don't have to tell you this. Customer healthcare, banking, industrial, education. That's interesting for me. That kind of feature. Voice commerce and accessibility for disability. So now this speed, voice transmission speed is very fast. Khadija speaks in 90 milliseconds. In fact, it's far too fast, honestly, because humans don't always speak that fast. And that could be another problem. So now we measure the speed of the agent based on maybe a model of user which is not realistic and certainly not realistic across the segments, but that's another story. So we have emotion, we have context, and it's global. So there is no issue with technically latency, but there are issues when it comes to natural speech. Yes, so the state of the art is not in the research lab, in the research space, in the research lab, but it's in the startup. So if you want to see the latest, you have to go and look at what's on the market rather than what's in the paper. So when using, you said, okay, it's all there, I'm going to use it, and you try to use it, and it doesn't quite work like that for a number of reasons. So I have conducted some studies across a number of use cases. And what has emerged is that the main problem is that the system, this is being generalized. They can provide more detailed figures as to which model, when, or how it was used. But in general, we can say that natural conversation is not continuous. It's made of pauses, of utterances, and systems just struggle with that. Plus, in a normal conversation, you could go back and say, ask your you're speaking with saying, what did you say? Or you repeat that, and with the machine, it's still not always straightforward. So the user expectations are not met, and the system has a number which I am studying in detail, and the published research, backs my findings. So what I've found is consistent with research in the last couple of years. I am happy to share the sources for those who are interested. So, given the time, I can share test cases. For example, the interruption problem, where while the user is formulating a complex thought, it pauses, and the system detects the pause and assumes complete completion and interrupts. So many kind of stuff gets on with whatever, instead of making sure that the user has finished the space. And then it's impossible to have natural flow of thought. And this is all documented. I have a number of use cases which I can share. The critical gap, so is the usability. Systematically, we have found out that there are false assumptions, control removal, temporal inflexibility, cognitive mismatch, and I can present this in more detail. There is a disconnect between the technology and the usability of the technology, and I'm going to share some demos following this. And there is somehow the hypothesis that if we could standardize certain patterns, if these could be tested and adopted across the industry, they could help to improve the usability or address at least some of these problems. Some examples run along a stack of 5 components: interaction state machine, context management, interaction. So this is an interaction model. Context management is problem configuration schema. So I think there is a user preference. Different users have different modalities of speech. Task queue. It could be the user could say this is how the interaction is going to take place in structure, creating structure for that particular interaction, and recovery process. So these are standard patterns of software engineering that could be applied to the proposition here. The proposal is that they could be applied to voice AI. How could this be implemented? The suggestion is they can be implemented with the API, because these usability failures that are coming across very consistently throughout all the agents are not hardware problems, but they're interface control. And with voice for some reason hasn't defined as fast as other pattern media interfaces. And I have a bunch of use cases and about 5 API scripts that can be looked at if someone is interested. So please do get in touch. And thank you very much.